Here we are looking at the Pre-AP Unit 3C test retake practice. So to start with, we're just simplifying these imaginary and complex numbers. So I've got 2i times negative 4i times negative 3i. Just multiplying one part at a time. 2i times negative 4i gives me negative 8i squared. But we need to remember that I squared equals negative 1. So this is negative 8 times negative 1, or positive 8. And then I need to multiply that by negative 3i. So when I multiply 8 times negative 3i, that's going to give me negative 24i. Question 2. For this, when I have addition or subtraction between my complex numbers, I'm just combining the like parts. So I'm going to add or subtract the real parts and add or subtract the imaginary parts. So I've got 3 plus negative 8, which gives me negative 5 for my real part, and then negative I plus negative 3i is going to give me negative 4i for my imaginary part. Question 3 is very similar to that, only I'm doing subtraction, but I still put my real parts together. So I have 5 minus negative 2, that's going to be 7. And then I have 6 minus negative 4, so that is plus 10i. Because when you subtract a negative, you are adding the positive of it. Okay, looking at number 4, here, I do not have the addition or subtraction sign between it, so this is where I am multiplying these. So I need to FOIL this. So I've got 4 times negative 1, which is going to give me negative 4. Then I have 4 times 3i, which is going to give me 12i. Then I've got negative 2i times negative 1, which gives me plus 2i. And I have negative 2i times 3i, which gives me negative 6i squared. I want to combine like terms, so I have negative 4 plus 14i, and then just like what I have here of I squared equals negative 1, so this I squared is negative 1, so that's negative 6 times negative 1, so plus 6, and combine those parts. So I have 2 plus 14i. Follow that same process for number 5. So I do negative 15. Then I've got 5 times negative 6i, so minus 30i, 2i times negative 3 minus 6i, 2i times negative 6i minus 12i squared. So I've got negative 15 minus 36i, and then this I squared is negative 1, so that's plus 12. So I can now add those two together. So I have negative 3 minus 36i. Same process follows for question 6. So I do negative 6 times negative 6, which is 36. On the outside, I have negative 6 times I, so minus 6i. Negative I times negative 6 is going to be plus 6i. And negative I times I is going to be minus I squared. So I've got 36. This minus 6i plus 6i, those cancel each other out, so I'm just have the minus I squared, which is plus 1. So I get 37. The reason these multiply together to give me a real number, I no longer have any imaginary parts, is because these are conjugates of each other. The conjugate is where I have the same values in each of those, but one is addition and one is subtraction. For 7 and 8, it wants us to use the quadratic formula to solve these. So the quadratic formula is given to me up here. I need to first identify my A, B, and C values. So my A value is the coefficient of the x squared term. So here A is 4. B is the coefficient of my x value, so that is negative 3. And C is my constant, the one that doesn't have an x with it, so that is 1. Once I know my A, B, and C values, I can just plug those values where they belong in my quadratic formula. So I've got negative B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. And now I just want to simplify this. So the negative of negative 3, so that gives me 3 plus or minus the square root of 9 minus 4 times 4 times 1 is 16 over 8. So I've got x equals 3 plus or minus the square root of negative 7 over 8. When you get to here, you want to simplify this square root as far as you can. There's not much that I can do with this, but I can take that negative out. So I have x equals 3 plus or minus I root 7 over 8. Question 8, I want to do that same process, but first I need to set this equal to 0, that way I get the correct C value. So I have x squared plus 4x minus 8 equals 0. Now I can label my A value is 1, my B value is 4, and my C value is negative 8, because that, when it's set equal to 0, that C value is negative 8. I plug into my quadratic formula. So I have negative 4 plus or minus the square root of 4 squared minus 4 times A, which is 1 times negative 8 for my C, all divided by 2 times 1. I'm going to simplify this. So I've got negative 4 plus or minus the square root of 16. Negative 4 times negative 1 times negative 8 is going to give me positive 32. So I'm going to move multiple. So it'll be 16 plus 32 that I take the square root of. That's all divided by 2. So I've got negative 4 plus or minus the square root of 48 over 2. So now I want to take and simplify that square root as best that I can. The square root of 48 that is the same as saying the square root of 16 times the square root of 3. And we know that the square root of 16 is 4. So we've got negative 4 plus or minus 4 square root of 3 over 2. If you are able to, you want to simplify this fraction. So both those are divisible by 2. So I get x equals negative 2 plus or minus 2 square root of 3. For 9, 10, and 11, we want to solve these by factoring. The way we factor this, that is our x factor, where up top we want it to multiply to my a value times my c value. So it needs to multiply to negative 20, but add to be my b value, so it needs to add to 1. Looking for two numbers that multiply to negative 20, but add to positive 1, that's going to be 5 and negative 4. But I need to remember that I have to divide those by that a value. So divide those both by 2. If you can simplify your fraction, simplify that. Okay. If it simplifies into a whole number, that is going to be one of your factors. So you have x minus 2. If it did not simplify, what's on bottom goes in front with your x, and what's on top goes behind. So that equals 0. Once you have it in factored form, which is what this is, I can now set each of these factors equal to 0. So here I have x minus 2 equals 0, or I've got 2x plus 5 equals 0. I'm going to solve each of those individually for x. So here I'm going to add 2 to both sides, and I get x equals positive 2. Here I'm going to subtract 5 from both sides, so I have 2x equals negative 5, and then divide both sides by 2. I get x equals negative 5 halves. So those are your solutions. X equals 2, x equals negative 5 halves. Looking at 10, before I factor this, I want to set it equal to 0. So I've got 2x squared plus x minus 6 equals 0. So now I can make that x, I want it to multiply to negative 12 because it's 2 times negative 6. And I want it to add to 1, so that's the coefficient there. So two numbers that multiply to give me negative 12, but add to give me positive 1 are 4 and negative 3. And then I need to remember to divide by that a value. So divide both of those by 2. If it can reduce, reduce it. So I've got x plus 2 is one of my factors. The other factor, it's on bottom, goes in front with x. What's on top goes behind it. Once I have it in factored form, I can set each factor equal to 0. So I have x plus 2 equals 0. I have 2x minus 3 equals 0. To solve this one, I'm going to subtract 2 from both sides. X equals negative 2. To solve this one, I add 3 to both sides, so 2x equals 3. And then divide both sides by 2, and I have x equals 3/2. So those are my solutions. X equals negative 2, and x equals 3/2. Looking at 11, this is already set equal to 0, so I can make my x. I need it to multiply to 36, because that's 9 times 4. I need it to add to be 12. That's going to be 6 and 6. And then I need to divide both those by my a value. So divide both of those by 9. If it can simplify, simplify it. So both of these simplify to 2 over 3. So I have 3x plus 2 times 3x plus 2 equals 0. So I say 3x plus 2 equals 0. 3x plus 2 equals 0. I'm going to subtract 2. 3x equals negative 2. Then divide by 3. X equals negative 2/3. And I'll get the same result here because those were the same factor. So for this one, I only have one solution, so I only need to write it the one time. It's just x equals negative 2/3. Okay, looking at the next sheet. Questions 12, 13, and 14 want us to solve by taking the square root. Solve using the square root method. To use the square root method, I need to get what is squared alone. So here, it is the x squared that I need to get alone. So I'm going to subtract 49 from both sides. So I have 4x squared equals negative 49. And then I need to divide both sides by 4. So I have x squared equals negative 49 divided by 4. So there were 3 things to remember with this. The first thing to remember is before we take the square root. Before we take the square root, we want what is squared to be alone. So we've accomplished that. The second thing we need to remember is while we take the square root, when we take the square root of these, I need to take both the positive and the negative square root. So x equals positive and negative square root of negative 49 divided by 4. And this I'm going to want to simplify. When you take the square root of a fraction, what you really have is the square root of the top, so square root of negative 49, divided by the square root of the bottom, square root of 4. So I have x equals positive or negative square root of negative 49 divided by square root of 4. Each of these radicals I am able to simplify. I have x equals positive and negative. Square root of negative 49 is going to be 7i. The square root of 4 is 2. So I have x equals positive and negative 7i divided by 2. So looking at 13, what is squared is already alone. So I can just immediately take the square root of both sides. Remembering, when I take that square root, I need to take the positive and the negative. So I have 2x plus 7 equals positive and negative square root of negative 100, which the square root of negative 100 is 10i. So 10i. So the third thing that we needed to remember, so the first one was get what's squared alone. The second thing to remember is when I take the square root, do the positive and the negative. And then the third thing to remember is after I've taken the square root, I want to simplify completely and solve all the way for x. So I still need to get the x alone. So I'm going to subtract 7 from both sides. So I have 2x equals negative 7 plus or minus 10i. And then divide both sides by 2. So I have x equals negative 7 plus or minus 10i all over 2. And you could break this up and do negative 7/2 plus or minus 5i, but leaving it just like this because not both of them are divisible by 2, that's fine. So looking at 14, again, what is squared is already isolated. So I'm going to take the square root of both sides. So I have 5x minus 4 equals positive or negative square root of 96. The square root of 96 that I want to simplify out. I'm going to say that is the square root of 16 times the square root of 6. So that's going to be 4 square root of 6. So I've got 5x minus 4 equals positive or negative 4 root 6. To solve this all the way for x, I've got 5x equals 4 plus or minus 4 root 6. When I divide both sides by 5, I get x equals 4 plus or minus 4 root 6 all over 5. Questions 15 through 17 want us to solve these inequalities. We will use the sign chart and put our solutions in interval notation. When you're doing these, you first need to identify your zeros. So 15 and 16 are already factored. We're going to need to factor 17 to find our zero values. So when it's in factored form, I set each of those equal to 0. So I get solutions x equals 0 at 0. And here, x would equal positive 7. My sign chart is a number line that has those 0 values marked. So I've got 0 and 7. Because I have a negative leading coefficient, that means my parabola would open down. So the sign chart is saying here, if I look left of 0, if I look at x values less than 0, my graph is found below there, so that's going to be negative. Between 0 and 7, my graph is above there, so that is a positive value. And greater than 7, it's found below, so that's a negative value. I then need to look, what is my inequality? This wants values that are greater than 0 or positive. So I'm going to say, well, the positive interval is from 0 to 7. And it doesn't want or equal to, therefore I close it with parentheses, remembering my interval notation. So for 16, here I've got x equals 5/3, and here I have x equals -4. So I make my sign chart, putting those values on. Because the number line is going to go lowest number to highest number, so I've got -4, and then I've got 5/3. This leading coefficient is positive, so it would open upward. So I say if it's left of -4, that's above, so that's positive. Between -4 and 5/3 is below, so it's negative. 5/3 on is positive. This one, I now look at what the inequality is. This is less than, so it wants to know when it's negative. So I say the negative area is between -4 and 5/3. And because it cannot equal, I close it with parentheses. So for 17, before I can make my sign chart, I need to get this into factored form so that I can find those zeros. So this, I'm looking for two numbers that multiply to give me -8, but add to give me -2. So that's going to be x minus 4 and x plus 2. Therefore, my zero values are when x equals 4 and when x equals -2. So I'm going to make my sign chart. -2 comes first, and then 4. And this has a positive leading coefficient. So that would be where my graph would be. So values, x values less than -2 are positive. Between -2 and 4 are negative, and greater than 4 are positive. Now I need to look at what the inequality sign is. It wants values that are greater than or equal to 0. So I've got two places that it's positive. So I need to write my interval for both of them. So I've got from -infinity going until -2. And it says or equal to, so I close it with a bracket there. And then I have the union saying, and also from 4 going to infinity. Okay. For 18, 19, and 20, we are solving the systems. So we need to make sure that these are set equal to, each equation is set equal to y first, so that we can then set the equations equal to each other. So I've got x squared plus 3x minus 5 equals x plus 3. Now I need to move everything over to one side, that way I'm able to solve for x. So I have x squared plus 2x. When I subtract 3, that's going to be minus 8 equals 0. This one, I can choose any method that I want to solve for x. I could try doing square root method, so I could complete the square to do the square root method. I can try factoring, or I can do the quadratic formula. I can see that this is going to factor because there is a number that multiply. There are two numbers that multiply to -8, but add to +2. That's going to be x plus 4, and x minus 2 equals 0. So I set each of those equal to 0. I have x equals -4. If I set x minus 2 equals 0, I add 2 to both sides, and I have x equals +2. Now, because this is a system, I need to find also the y value that is going to go with that. So I put -4 in to this linear one. So -4 plus 3 is -1. So one of my solution points is -4, -1. The other one, I put 2 in. So I get 2, 5. Those are my solutions. Follow the same process here. I'm going to set the equations equal to each other. -2x squared minus 4x minus 1 equals 2x plus 4. So move everything over to set it equal to 0. So I've got -2x squared minus 6x minus 5 equals 0. And again, I can choose any method that I want to be able to try and solve this one. This one is not going to factor for me. So what I'm going to do, I'm going to use the quadratic formula here to find my x values. So I have 6 plus or minus the square root of 36 minus 4 times -2 times -5 all over 2 times -2. So that is 6 plus or minus the square root of 36. -5 times -2 is +10 times 4 would be 40. So minus 40 all over negative 4. So that is 6 plus or minus the square root of negative 4, which the square root of negative 4 is 2i. Over negative 4. So I want to simplify this as best I can, and I get my two x values. I get x equals 3 plus I divided by 2, sorry, negative 3 plus I divided by 2. My other x value is negative 3 minus I divided by 2. Now I need to put those values in for x in my linear equation. So when I put this in, I get the x value is negative 3 plus I divided by 2. The y value there, when I multiply that by 2, those go away. So I have negative 3 plus 4, which is just 1 plus I. And here, I have the x value of negative 3 minus I divided by 2. I plug that in. So when I multiply this by 2, I just have the negative 3 minus I, and then I have to add 4, and I get 1 minus I. So those are going to be my solutions there. Looking at number 20, I'm going to set these equations equal to each other. So I have x squared plus 5x minus 2 equals 3x minus 2. Move everything over to one side. I have x squared plus 2x equals 0. So here, I can factor an x out of both of these. So I have x times x plus 2 equals 0. This is the factored form. So I'm going to set each of those factors equal to 0. And I say x equals 0 or x equals negative 2. And then I need to plug those values back in. So if I put 0 in, that's 0 minus 2, which is going to be negative 2. So it's going to be the point 0, negative 2. And if I plug negative 2 in, that's going to be an x value of negative 2. And then negative 2 times 3 is negative 6. Minus 2 more gives me negative 8. So there is my solution set there. Okay. For question 21, it gives me the roots and a vertex, and it wants me to write the equation in all three forms. It wants me to write it in vertex form, in factored form, and in standard form. If it gives me the vertex, the first thing I have to do is I need to find A. So to find A, my roots give me additional points. So my roots always have a y value of 0. So I'm going to use vertex form to figure out what my A value is, plugging in what I know about the roots and my vertex. So vertex form is y equals a x minus h squared plus k. My vertex gives me h and k values. My roots give me x values, and the corresponding y value with that is going to be 0. So I've got 0 equals a times 2 minus 4 squared minus 12. That's going to be 0 equals 2 minus 4 is negative 2, squared is 4. 4a minus 12. So I add 12 to both sides. 12 equals 4a. So a then equals 3. Knowing my a value, I can write my vertex form. It's going to be y equals 3 x minus 4 squared minus 12. Also having my a value and knowing my roots, I can give my factored form. My factored form is going to be y equals a, so 3, and then I have x minus my first root, so x minus 2, and x minus my second root, x minus 6. That is my factored form. To get standard form, I can really go from either one of these and expand it out. I'm going to go from factored form. So I would need to FOIL x minus 2 and x minus 6. I'm going to FOIL that out. So I have x times x gives me x squared. X times negative 6 is minus 6x. Negative 2 times x is minus 2x. Negative 2 times negative 6 is plus 12. So I have x squared minus 8x plus 12. But I need to remember that all of that is being multiplied by 3. When I multiply that 3, it needs to distribute to all parts of this. So I end with y equals 3 times x squared is 3x squared. 3 times negative 8x is going to be minus 24x. And 3 times 12 is going to be plus 36. So there I have my 3 different forms for those roots and that vertex. So the last one we're working on, 22, again, it's giving us our roots and it wants us to put it into standard form. When it gives us our roots, we want to set those roots equal to 0. Sorry, not equal to 0, equal to x. So I have x equals negative 3 plus or minus I square root of 11. When you are dealing, when you have a plus or minus one, what we want to do, we want to work this backwards. The only way we get the plus or minus is when we take the square root. So we want to undo the square root method. So I'm going to add 3 to both sides here. So I have x plus 3 equals positive or negative I square root of 11. How we get that positive or negative is if we had taken the square root. So we do the opposite of that, and now we square both sides. That's going to give me x plus 3 squared equals, well, I is the square root of negative 1, so that is the square root of negative 11, square root of negative 11 squared is just going to give me back that negative 11, working it backwards. And then I add 11 to both sides. So I have x plus 3 squared plus 11 equals 0. Now this is not standard form. We need to FOIL this. We need to do that squaring and add 11 to get it to standard form. So I have x plus 3 times x plus 3. So that's going to be x squared plus 3x plus 3x plus 9. So x squared plus 6x plus 9. And then I have the plus 11 that I need to add to this. So my standard form equation that has the roots of negative 3 plus or minus I root 11, my standard form equation is going to be y equals x squared plus 6x plus 20.